Welcome to Kapardi Maths Classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 8th video on single variable calculus. Now in this video I am going to discuss about classification of the functions. Okay, now why do we study the calculus? What is the main objective of studying a calculus subject? It's very simple. A working rule will be given and you have to study the behavior of that working rule. Very simple. A working rule will be given. You have to study the behavior of that working rule. Okay. Now before entering into advanced level of study, we need to learn some basics. We need to learn some basic functions. Okay, now there are around almost 36 to 40 functions are there. Maybe polynomial function, rational function, exponential, modulus, trigonometric functions, inverse trigonometric functions, like that. Around 30 to 40 functions are there. Okay, to remember those functions, I divided the functions into 3 categories. That is now the classification of functions concept. Now the functions basically categorized into 3 classes or 3 types. What are they? First, number 1 is algebraic function. Next one you have, second one is transcendental. And third one you have piecewise function. Now again in an algebraic function you will find polynomial. Next one you have rational. Next one you have irrational functions. Whereas in transcendental function you have exponential function, logarithmic function, and you have trigonometric functions, inverse trigonometric functions, trigonometric functions, and whereas in piecewise function, first well-known function is modulus, and you have signum function, you have greatest integer function, and fractional part function, and finally you have least integer function. Now in the coming lessons I am going to discuss about each and every function, graph definition of the function, graph of the function, domain of the function, range of the function. If you know all these 4, studying the advanced level is very easy. Please take it. Now these algebraic functions are classified into number 1, polynomial function. Number 2, rational function. Number 3, irrational function. Let me discuss one by one. Let F maps domain of F2 range of F defined as f of x is equal to a naught x to the power of n, a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 and so on, ar x to the power of n minus r and so on plus an, where a naught is not equal to 0, 0.1. The next one, all these coefficients a naught, a1, a naught, a1, a2 and so on, an, all are real numbers. They cannot be complex. And moreover, this n must be positive integer. For any function which is in this form and satisfies all these conditions, then only that function is called polynomial function. It is called function. Now, because the working rule is a polynomial, so it's called polynomial function. Now, based on the size of this n, based on the volume of n, we can give names to these polynomial functions. Based on the size of n, what are the different names given to this polynomial function? Number one, very simple. If n is equal to 1, my function will become f of x is equal to a naught x plus a1, and you know very well this is called linear function. Number 2, if n is equal to 2, we have f of x is equal to a naught x square, a1x plus a2, the well known function, quadratic function. Quadratic function. And if n is equal to 3, my f of x will become a naught x cubed, a1 x square, a2x plus a3, which is called cubic function. And we have one more name. If n is equal to 4, my f of x will become a naught x to the power of 4, a1 x cubed, a2 x square, a3x and a4, and this is called biquadratic Okay, now my next point is, what is domain of this polynomial function? What is a domain of the polynomial function? What the meaning of domain? The acceptable set of real numbers as the inputs. If you observe carefully, I can substitute any real number in the place of x. No restriction, because it accepts every real number. So, my domain for this polynomial function, my domain is a real number set. What is about the range? Now, range depends on the working rule. Again, working rule depends on n value. So, for each one, the range will change. Now, the range of the polynomial function depends on working rule. F of x is equal to, we have a naught x to the power of n plus a1 x to the power of n minus 1 and so on plus an. If n is an odd number, definitely the range is an entire real number set. So here range if n is odd, then the range of polynomial function is a real number set, or I can say minus infinity to plus infinity. And if n is an even number, when n is even number, the range depends on the working group. I will explain you that also. If n is even, the range depends on the working group. Then how do you find the range? Now in advanced level of calculus, we have so many methods to find the range of the function. Look here. For example, I have f of x is equal to the linear arithmetic a naught x plus a1. If you observe carefully, the graph of the function 0, x-axis, y-axis, my graph somewhere here. Of course, the graph position depends on a naught and a1. We know very well how to draw a linear graph. Now, if you observe, I can extend these both ends infinitely. Therefore, my range starts from minus infinity, ends with plus infinity. Therefore, the range is equal to here minus infinity to plus infinity. Or if you take f of x is equal to, example 2, f of x is equal to y is equal to x square. And you know very well, there is a parabola. The graph of this function will be like this. And the range here 0 to infinity. 0 included. Take one more example. Suppose f of x is equal to, I can take x cube, which is cubic, and the graph of this function will be like this. So 0, x-axis, y-axis, the graph, and minus infinity to plus infinity. In this case also, my range is minus infinity to plus infinity. So most of the, if n is odd, then definitely the range will be minus infinity to plus infinity. If n is even number, now based on the working rule, the range will change. I explained you only for second degree, even for fourth degree or sixth degree or eighth degree, we have very advanced level methods to find the range of the function. At this stage, no need to worry. Two more special functions are there. Number one is constant function. What is the definition? Again, f maps domain of f2 range of f defined as f of x is equal to some k where k belongs to real number. Then this is called constant function. Now, what is the domain? Domain, because it is a polynomial function, the domain is Of course, real number set. What is the range? Now, for that, I take the help of the graph. F of x is equal to k. If k is positive, my graph will be like this, and this distance is equal to k units. Therefore, this for all values of x, it produces only k. Therefore, my range will be singleton set k. And one more, we have identity function. Identity function. F max domain of F2, range of F, defined as f of x is equal to x. That means my input and output both are same. Therefore, my domain will be, of course, a real number set. What is the range? The range is also real number set. Why? Because input and output both are same, and the graph of function will be straight line passing through origin. And here also negative infinity to positive infinity. Okay. Yes. Function. A rational function. How it is defined? Again, f max, domain of f, the range of f, defined as f of x is equal to p of x by q of x, where p of x and q of x both are polynomials and q of x is not equal to 0. It's very, very important. Then what is the domain? My domain is equal to r minus x such that q of x is equal to 0. And how do you find the range? The range depends on, again, working rule, and the normal method, graphical methods are not suitable to find range. We have to go for advanced level like limits, continuity and differentiability. That's why I am not discussing about range of this function. So, but I write here range depends on the definition. Okay. Now look at some examples. Example, my f of x is equal to, I can go for 3x square plus 2x plus 1 upon x square minus 3x plus 2. So what is domain here? Domain is equal to r minus this x square minus 3x plus 2 will become 0 at 1 and 2. So I have to remove those things. In the range one, at this stage we don't know the range, but I will explain you in the when I am touching the differentiation part. Okay. One more also we can take example. F of x is equal to x square minus 2x plus 3 upon x. Here domain is nothing but r minus 0, because 0 you cannot substitute here. Next one, irrational function. Irrational function. Now, if that algebraic function contains a term whose exponent is a rational number, an algebraic function which contains a term whose exponent is a rational number of p by q form, then that is called irrational function. For example, look here, let one. It is f max, the function, domain of f to range of f. If f of x contains a term whose exponent is a rational number, of the form p by q, is called irrational function. Then what is the domain? What is the range? Depends on the working group. Domain and the range depends on the working group. For example, or it can be a rational form also. See, so both are irrational functions.